Alright, in this video we're going to put it all together. Calculations with reactions having gases. So let's play around a little bit with the information that we have and see what we get. Let's take a question like this. A reaction produces 98 milliliters of SO2 at STP. As soon as you see that, that should kick off something in your brain. At STP wants to know what mass of SO2 is present. The mathematics here is very, very simple. If you give them a second to copy the question, then we'll work it together. Alright, as soon as you see it says at STP, you should automatically think 1 mole equals 22.4 liters. Doesn't matter what gas. Okay? And I should go ahead and say this is a gas. I said the words, I forgot to write it. 98 milliliters of sulfur dioxide gas. Alright, so this is going to be important to us here in a second. So let's take 98 milliliters and we're going to set up a railroad track. But I have a problem. You'll notice that this is in liters and this is in milliliters. Well, that's an easy fix. If I want this in milliliters, I back the decimal up 3 spots. 1, 2, 3. So now I've just converted this into a unit I can use, 0.98 liters. So liters can be converted into moles. Very simply, 22.4 liters equals a mole. And so if I take my handy dandy calculator, 0.098 divided by 22.4 is 0.004375 moles. But I have a problem because it says what? Mass. Okay, well then I'll just take moles and change it to mass. Mole to grams. What number always goes with mole? 1. 1 mole is grams. Grams come from the chart. And since it's SO2, sulfur is 32, oxygen is 16 times 2 is 32, grand total 64. So I'm going to take that number I had on my calculator times 64, and it's 0.28 grams. Notice I just converted liters to grams because of this fact right here. Mole is 22.4. Now remember, it's only true at STP. If it's not STP, then you cannot use that. But in this case, you could. Not too difficult math. Let's try another one real quick. Then I'll have you try one. Let's say you have one like this. You have 77.8 grams of nitrogen dioxide gas. 77.8 grams of nitrogen dioxide gas at STP. And you want to know the volume in liters. Alright, let's see if you can do this one on your own. It's sort of the reverse of the other. Pause the video, I'll come back in a minute, we'll work it together. Alright, if you had 77.8 grams of NO2, railroad track, grams, the only thing you can take grams to is moles. 1 mole is grams, that comes from the chart. Nitrogen is 14, oxygen is 16 times 2 is 32, grand total 46. So I'm going to take 77.8 divided by 46. Answer 1.69 moles. But it wants to know the volume, and because it says at STP, I know that 1 mole is 22.4 liters. So 1.69 times 22.4, I just converted that to 37.9 liters. This is how you convert using gases. If you have gases and you need to convert between them, if it's at STP, that magic 22.4 number works every single time. So that's sort of the magical part of it. If you read it and it says at STP, be looking for a way to use 1 mole is 22.4 liters. Alright? So how does this work in an actual reaction? Alright? So we know how to convert between it. let's see what this looks like in an actual reaction. Let's say you have a reaction like this. C3H8 plus 5O2 yields 3 CO2 and 4 water. All right, now I'm going to go ahead and give you the important information. In this case, every single one of them is a gas. And if you remember back, there was a time in which we used to put the phases in there, and this is sort of why we do it, because at this point we now can work the problem. Okay? And so in this case, you're talking about propane gas, and in this case, this is a combustion reaction, and you know how to balance this. You've done it before. Okay? The question says, what will be the volume in liters of oxygen? Okay? You want to know this in liters. If you had 0.350 liters of propane that's going to burn. Now you could calculate this and you could calculate this, but it only asks for this. So remember, when you're going to do calculations with reactions, you want to be in the unit of moles. Now when you read through the question, and I'm going to read it all together for you, you have a reaction that takes place at standard temperature and pressure. And so we're going to go ahead and write at STP just to make sure we have that. And they want to know from here to here. Okay, well I know that this is a 1 and that's a 5, so that's going to be easy to do if I'm in moles. So what I'm going to do is I'm going to take 0.350 liters, railroad track. 22.4 liters equals a mole. How can I do that? Because I'm at STP. Alright, so 0.350 divided by 22.4, answer 0.016. 0.016 moles. Now that I have this, can't I calculate that in moles? 0.016 divided by 1 is 0.016. Multiplied by 5, so 0.016 times 5, that is 0.08 moles. But the question doesn't want moles, it wants liters. Then I just change it right back. Mole, liters. 22.4 liters is a mole. So I take 0.08 times 22.4. The grand total answer is 1.8. So I actually get 1.792, but at 1.8 rounded liters. There's my answer. 1.8 liters. The mathematics there is not very difficult. It's the same as jumping columns. Remember, the only way to move between columns is in moles. So I converted liters to moles, and then I did my normal math. This divided by this times 5 gives me this answer in moles. Convert it back to liters. Because I'm at STP, I've got my answer. Pretty simple mathematics to do. All right? So this is how you use liters when you're doing a reaction. Okay? And so notice, since everything is gas, that's how it works. All right? Now, let me ask you this real quick. Let's say, this is wrong, but let's say when you look at a reaction that it was solid, liquid, liquid, liquid. Can you use 22.4 liters even if it is at STP? The answer is no. Because 22.4 liters, by definition, if you go back, 1 mole is 22.4 liters of gas. And it only applies to something that is a gas. So 22.4 liters will not work with solid or liquid or aqueous. It can only work with gases. Okay, so when you need it, you can apply that with any of the equations that you have. Let's try one more, and you can practice a couple on your own. Let's say we want one like this. You have calcium carbonate, solid, decomposes into calcium oxide, which is a solid, and carbon dioxide gas. All right, now some things that should jump out at you. Solid, solid, gas. All right, as you read through it, it says how many grams of calcium carbonate, wants to know how many grams of calcium carbonate must be decomposed to produce 5 liters of carbon dioxide at STP. Alright, so we're going to start here, and we're going to get our answer here. Notice there's the magic phrase you're looking for at STP. So you're going to take 5 liters, and 22.4 liters equals 1 mole. Alright, first you need to make sure you have coefficients right. Calcium, carbon, calcium, calcium, 1 carbon, 1 carbon, 3 oxygens. So it's a 1, 1, 1. That's easy here. So 5 divided by 22.4 is 0.223 moles. Okay? Since that's a 1 and that's a 1, this is 0.223 moles. Railroad track, because they want grams, moles, grams. Now, do I want to go to liters? Nope, that's a solid. So I want to go to grams. So 1 mole is, how much does this weigh? Carbon is, calcium, not carbon there. Calcium is 40, carbon is 12, oxygen is 16 times 3 is 48. Add those numbers together, I get 88, and I have 100. 0.223 times 100 is 22.3 grams. Now you'll notice that when I work this problem, the mathematics are pretty easy to do. It's the same that we have been doing when we do calculations with reactions. The difference is if you have a gas, this extra weapon can help you, this 22.4 liters, if you're at STP. In the next video, I'm going to work a question in which, what do you do if it's not at STP and you have gases? How do you work that? Well, we'll see you in the next video.